Hello again and welcome back to Operations Management. We're continuing with statistical process control, and now we're going to be looking at how we create control limits for P charts and C charts. If you recall, P charts and C charts are used for attribute inspection in terms of is there a defect, is there not a defect. A P chart is used to monitor the percent or fraction of defective units within a sample. So when you're thinking about P charts, think percent defective. We have a total number of items in a sample, and we're just counting how many of them are defective. When we go to create the upper and lower control limits, just like we've done before, we're going to take the mean and we're going to add a number of standard deviations above the mean, and then we're going to take the mean and subtract the number of standard deviations below the mean for the lower control limit. One thing to remember with a P chart is we actually have to calculate the standard deviation of P. And to do that, we need the mean percent effective or the average percent effective, and we also need the mean sample size. So in this case, it would be the square root of P bar times 1 minus P bar over N bar. Now, typically we use 3 for Z because we typically use 3 standard deviations away from the mean. So here we have an example. The LRDR company is trying to monitor the number of defective batteries that they make. It's been determined that the average percent defective in a sample of 50 is 2%. So we're going to use 3 sigma control limits and calculate an upper and lower control limit for a P chart. So the first thing we need to do is we need to calculate that standard deviation of P. We know that the average percent effective is 2%, which is 0.02, and our sample size was given as 50. So we make those substitutions. P bar is 0.02 and N is 50, and we can calculate that sample, the standard deviation for the percent effective. From there, we can create our upper and lower control limits. P bar plus 3 times the standard deviation, P bar minus 3 times the standard deviation, and so our upper control limit is 0.0398 and our lower control limit is 0.0002. So when we have our control limits and we have our control chart, that lower control limit is our lower line on the chart, and the upper control limit is our upper line on that chart. As long as our data points, we're going to be collecting samples of data, calculating the percent effective in that sample. As long as that percent effective falls between these two limits, we consider the process in control. If it falls outside the control limits, we say it is not in control, and we start looking for an assignable cause. A C chart is a little bit different. Instead of looking at a percent effective, we're actually looking at a count of defects within a sample, which means there can be more than one defect in a particular product. For example, if we're looking at a car, there could be a flaw in the paint, there could be a flaw in a windshield, there can be a flaw in a light. That would be 3 separate flaws, and each one of them counts towards this C chart. So there can be more than one defect on a unit. So we calculate the upper control limit by using C bar plus Z times the square root of C bar, and the lower control limit of C bar minus Z times the square root of C bar. And typically, again, Z is 3. So we have 3 standard deviations from the mean, and C bar is the average number of defects, or the mean. So here we have another example. This one is concerned with the number of defects in painted panels, and the average number of defects in a sample of 100 is 2. The company wants to monitor the process. We're going to use 3 sigma control limits, and now we're going to calculate the upper and lower control limits for a C chart. We know the average number of defects, 2, so that's C bar. And then we simply create the upper and lower control limits by taking C bar plus 3 times the square root of C bar and C bar minus 3 times the square root of C bar. So we have 6.24 is our upper control limit, negative 2.24 is lower. Now you can't have a negative number of defects, so in this case we convert that lower control limit to 0. And in fact, anytime we have a control limit where it's negative and it is impossible to have a negative number, we convert that to 0. So that's all there is to creating the control limits for C charts and for R charts. When we use them on a control chart, the upper control limit is our upper line, the lower control limit is our lower line, and then we're just plotting the data in between. As long as that data point stays between those lines, our process is in control. If it falls outside, we say it's not in control. That's it for control charts. Have a good day.